We've introduced the idea of functions with multiple independent variables. So now it's time to start reintroducing the concepts that we've covered in calculus to now apply to these multivariable functions. In particular, in this module, we're going to talk about partial derivatives and look at marginal productivity. So when we talked about derivatives before, we looked at marginal cost, marginal profit, things like that. So marginal productivity is going to have is going to be a similar concept, but related to productivity rather than profit, costs, or revenue. But let's get started. Now that we have equations with multiple independent variables, we need to look at how to differentiate these types of functions. Previously, we introduced multiple different notations for how to indicate the fact that what we want to do is take the derivative of a function. So we express that as dy over dx, meaning take the derivative of some expression y with respect to x, take the derivative of some function f with respect to x. We could have written that as d over dx of that function f of x, or f prime of x. So we had multiple different notations that we could use to indicate that same question, or that same expression. Find the derivative of this function. With multivariable functions, we're going to calculate what we call partial derivatives. And what we mean by partial derivative is that we'll differentiate with respect to one of those variables. So this is where that dx portion is going to come into play very specifically in a very important way. So meaning we're going to differentiate with respect to one variable and treat the other variable as a constant. So before we can take these partial derivatives, we'll have to indicate whether we're differentiating with respect to x, with respect to y, with respect to z, with respect to whatever variable it is we're going to differentiate with respect to. So we'll have some new notations that we need to introduce to make it clear to express what it is that we're after. So part of these new notations is going to be this symbol delta. So this is the Greek letter for d, and it's just kind of a curvy d shape, but you can think of it as kind of meaning the same thing as dy. But what we're saying now is we want to find delta z over delta x. So that means take the derivative of some function z with respect to x. We could take the derivative of some function z with respect to y. So those are two notations that match up pretty closely with the notations that we had here. What we won't have is an f prime notation, because f prime really only works when there's one variable. So what we need is a way to distinguish the specific variable we want to differentiate with respect to. So what we'll do is write it as f subscript x, x comma y. So this means take the derivative of f with respect to x. We could also take the derivative with respect to y, or we could shorten up either of these two notations and just write f sub x or f sub y. Again, each one meaning take the derivative of f with respect to x, take the derivative of f with respect to y. So if we can find first derivatives, we can also find second order derivatives. So to find second order partial derivatives, we're going to be differentiating twice. So each time we differentiate, we'll have to indicate with respect to which variable we're differentiating. So this means that we can find f sub x, which means we first differentiate with respect to x, and then the second derivative differentiate with respect to x again. We can also find f of x sub y, f sub xy. So that would mean differentiating with respect to x, and then differentiating with respect to y. We could find f sub yy, which would mean take the derivative with respect to y, then the derivative with respect to y, or f sub yx, so we take the derivative with respect to y, then the derivative with respect to x. So these are the primary notations that we'll use for second derivatives, but there are a couple of other ways to represent this. We could also write this as delta squared z over delta x squared. So those two things mean exactly the same thing. Or we could say take the derivative with respect to x of delta z over delta x. So again, we're just taking the derivative of something we've already taken the derivative of. And these same notations would apply for each of these different cases. Delta squared z, and then now this changes since the variable changes. We would write this as delta y, delta x. So we're first taking the derivative with respect to x, then with respect to y. Or we could rewrite that as delta over delta y of delta z over delta x. So again, the first thing we'll work is this. We'll differentiate with respect to x. Whatever that result is, we'll differentiate with respect to y. And then again, we'll have very similar notations pop up for the other cases here. So keep in mind as you're reading these, even though we're using this new letter, this Greek symbol delta, it really is just the Greek letter for d. So again, it's just kind of a shorthand notation for differentiate. So we would have delta squared z over delta x delta y, which equals delta over delta x of delta z over delta y. So we have a couple of different ways those notations can be represented, but I think it's easiest just to see them represented this way. So if we do encounter one of these other notations, just think of it as f sub first variable we integrate with or differentiate with respect to, second variable we differentiate with respect to. And then the other thing to keep in mind when we're differentiating with multiple variables, that the other variable, so if we're differentiating with respect to x, then the other variable is y, then that variable remains constant. And the other thing to keep in mind is that all previous properties we've established still apply. So we don't need to relearn any different rules or formulas for derivatives. We'll still be using the chain rule, the product rule, the derivative rules for our simple functions like power functions, exponentials, and logs. So all of those rules still apply. The only thing that's really changing now is which variable we're differentiating with respect to, and then making sure we keep that other variable constant.